All right, in this video, we're going to look at the second problem from quiz 2. So there's actually a part A and a part B on this problem. They're both substitution problems. So we're trying to find an antiderivative by making a substitution. So remember, one of the first things we're looking for when doing a substitution problem is we're trying to find a function along with its derivative inside the integrand, or at least something that's its derivative up to a constant. So when I look up here, I see a t squared minus 4, and I know that the derivative of t squared minus 4 is 2t. And I can see, well, almost a 2t, right? There's a t, but it's only off by a 2, and that's a constant. So that gives me the inspiration to make the substitution u equals t squared minus 4. Now I can take the derivative and multiply by dt to get du equals 2t dt. Now I don't have 2t dt, I have t dt. But that's okay. I could multiply by 1/2, and then I would have t dt. All right, so that means I can rewrite this antiderivative problem as, let's see, well, let's get the e to the t squared minus 4. It becomes e to the u. And then t dt becomes a half du. So, okay, we can put a half there and a du there. Of course, this 1/2 I could also pull outside the antiderivative. And so now I'm really just trying to find an antiderivative for e to the u. Hey, that's not so bad. So I have a half still. Antiderivative of e to the u is e to the u. And of course, now I can back substitute my u equals t squared minus 4, and I'll get a half e to the t squared minus 4. Okay, if I want to check this, I take the derivative. Take the derivative, I can keep the 1/2. When you differentiate an exponential, you just copy the exponential. But then, of course, we have to, by the chain rule, multiply by the derivative of t squared minus 4, which is 2t. And hey, the half and the 2 cancel, and I'm left with t e to the t squared minus 4, which is what we wanted. All right, let's look at part B now. So again, I'm looking for a function whose derivative also shows up. And okay, let's see. Well, there's only a couple functions to deal with here. And ooh, tangent, what's its derivative? That's right, it's secant squared. So let's try that substitution here. U equals tangent of t. Then du will be secant squared t dt. Hey, that's exactly what we have in our antiderivative problem. I can rewrite this as, well, let's see, the tangent of t becomes a u, and then secant squared dt, that just becomes du. Okay, so I'm just trying to find an antiderivative for 1 over u. Okay, that's ln of the absolute value of u, and now I can replace my u with the tangent of t, and so I have ln of the absolute value of tangent of t.